Students, the most important group of people in the world. Students have a lot of influence on our society, and the good habits that they learn in their study time will be taken with them for the rest of their lives. For this reason, we decided to place the focus of our design goal on students. Our focal area was water and energy, which gave us some important questions to be considered. Where can conscious water and energy uses be promoted in their lives? What can they do to become more sustainable and have more future-proof habits? One of the things discussed in our long and extensive brainstorming sessions is that a lot of students have plans to liven up their sad and small rooms. However, plan care is difficult. It was then brainstormed on what solutions could be for this. This was done by first defining a Moscow list and then linking solutions to the requirements given there. We thought of a better way to water plants than watering plants with water. Our concept uses a large vessel combined with our beautiful rotating valve. This was combined with piping that leads directly to the plants. The concept works so that once every so often the vessel needs to be filled with water. 3 liters fit into the vessel, more than enough for multiple weeks for the maximum of 4 plants that can be watered. To understand when a plant needs to be watered, the product makes use of water sensors, which measure the soil and indicate when the soil is too dry to the Arduino. The multiple plants being watered is achieved by a rotating valve, which turns around to whichever pipe is connected to the dry plant. After this concept was designed, we decided to make some calculations and consider what would be matters of importance for our product. For the mechanical specifications, the size of the vessel was calculated, as well as the height needed for gravity to carry the water from the tank to the plants, since we're not using a pump, and what type of product will be 3D printed for the rotating valve. We also decided to specify the recyclability of the product, and now look more into the electrical and coding aspects which will be needed. For the code, it was of course of importance that the Arduino would recognize when the soil was dry and when it was wet, as well as recognizing what position the valve was in so it could be turned properly. The battery life was set to half a year so it would not have to be replaced too often. Of course, the electrical parts also had to be protected from water. Both parts separately looked into the aesthetics of their own parts. After these specifications, the product was made, and it's going to be demonstrated now.
Right now, the plant is wet. I'm gonna let go of it. Now it's dry, so now it's going to wet.
And the tank is almost empty. Get the lid off.
And now
It's flowing again.
And then when I hold this again,
It closes.
and then the water comes through.